Our next talk is a 30-minute talk including questions. And Adam Lowry will tell us about introspecting running Python processes. Adam Lowry is with a startup. Maybe he can say something about himself.
Thank you. So my name is Adam Lowry. I'm a co-founder and developer at Urban Airship. We provide services for mobile application developers. My colleague Michael Scherder, Schmeichel, as you might know, unfortunately couldn't be here with me, but he worked on this talk with me, and you can trust him because just look at that beard. And here's a picture of Michael in a Colombian drug runner submarine. So, just to get that going. So what I want to talk to you about today is, what is your application doing? What is your service doing right now while you're in this talk? Do you know? With any application, but especially with high-performance applications, you need to know what's going on. So how do you know that, say, your web application is behaving as you expect? You might have a monitor that hits it once a minute. You have logs, you have error email, or another set of error structures. But you are sort of estimating based on other knowledge. If everything ground to a halt without any change you made, could you identify the problem? And that's very difficult unless you instrument and expose the internal data of your application. All you can do is guess about the causes of the event. So to start out, to get a little bit of background, we could talk about logging, which you can consider your application's diary. You have an extreme of expected events, and you're throwing everything to disk. Everything is being persisted, and then you process and search as needed. But logging does have some downsides when you get into extremes verbosity. If you have a slow request, can you tell why it was slow? If you had a traceback or a 500, do you have enough of the local state in order to reproduce it or to tell what's going on? And the operational burden can be extremely large, even though there are certainly ways to work around that. Actually, did have one case where syslogd was the bottleneck in an application, so it can happen. But this logging is still vital for auditing and reference and a bunch of other uses, so you want to keep all of what you've got. There are some ways you could call breaking in through the back door. And this is digging into your application in some way that may not be entirely safe or entirely appropriate. There was an awesome talk here, I think it was last year, on GDB heap, digging into memory itself. There are backdoor modules where you can attach a REPL to a running process, or, well, that you have the capability built into it. Eventlet has one, so it spawns a green thread, and you can actually poke your Python process around, or poke around in an interpreter. And the actually debugger is a great example of what you could do when you have that power. In development, you have a 500-page or something. You could poke around at every level of the stack and even use the REPL to investigate what's going on. But all these things, they have trade-offs, and in general, you wouldn't say they're for production use. So to take a step back, I want to look at what we're missing when we use Python applications. Particularly want to look at the JVM. That's what I'm most familiar with outside of Python, and it's also what a lot of people that are writing services are using these days. So take a look at the Java management extensions. Any library application can expose a set of interfaces. Reading is not language agnostic, but you can expose this data via HTTP and JSON, and that is a terrible screenshot. It's kind of blurry, I'm sorry. But what you see on the right, on the left, is a hierarchy of packages that have information that you can pull out, and on the right is attributes and values. And any class or library can expose these values. The communication is actually two-way. You can put information back in or call methods, but this is sort of, you get this for free with the JVM. And it's traditionally used for resource consumption or system monitoring, but anything can make use of it. And this program that we're looking at, JConsole, is a GUI to connect to a running JVM and see what is going on. And so we were poking around at JMX attributes before, but this is just looking at some system information. There's the heap memory usage. You got that nice, happy sawtooth graph. And so this machine's pretty good. But this can be incredibly useful when you have a machine that's behaving somewhat badly. You can point this at it and see what's going on without knowing ahead of time what you're looking for. You have all this instrumentation available to you. The third one doesn't look as nice, but a JStack, it really is just sending a signal to the JVM, and then it dumps out the output of every running thread right now so that you can look at exactly what each thread is doing as it's going. And this is probably the most boring stack trace in the world. But you get the idea. When something bad is going on, this can give you a huge amount of information, and it's what is being processed right at that moment, not what activities have finished and have been logged. And this is built into the runtime. The last thing is not really something that is built into the JVM, but it's more of a cultural thing. Because these tools for retrieving information is good, but you have to have good instrumentation in order to expose the right data. And metrics is a library for instrumenting your application. All data is exposed by JMX or optionally with HTTP. But it's not just the tools. There's a mindset that knowledge about what is going on inside the application is crucial to operations. And that mindset gives you a lot more power when there are events or when you're doing capacity planning or other things of that nature. So I highly recommend that there's this presentation there, Coda Hale's metrics at CodeConf, and it's an extremely good presentation if you haven't already seen it. Now back to that JMX data that we looked at before, this is actually a metrics exposed bit of data on a running system. So these are measurements that are collected by it, and this is reporting a particular set of calls and how long they're taking. Like the 50th percentile through 99th is taking 1 millisecond, so that's pretty good. And it's only at the 999th that it bumps up. So we can be confident that this machine is running pretty well. With a variety of instruments, with a variety of measurements, you get more confidence that your system is behaving as you want it to. Oh, and here's one more bit of JConsole connected to JMX. My colleague Lucky wanted you to see this 1 minute graph down the bottom. So there's the 1 minute rate of activity, and he just clicked on that, and then it started graphing from that point, so you could see the change while you're watching it right then. So given that they have these different capabilities, what do we have available to us? And a couple of the approaches that some people are working on is, one is New Relic, of course, which there's a lot of the guys here, and they have a fantastic system for doing hosted web application monitoring. And because they're here, and I think they're in the expo hall, you should go get a demo from them and see what they can do. In Graphite, I know a lot of people are using these days. It's a scalable graphing system for time series data. So you poke data at it, and it gives you some graphs of what's going on. And it has a nice Python library for sending data to it from inside your application. What I'd like to do now, though, is talk about a few ways Michael and I have been working to instrument our Python processes. The first is a socket console, which is a terrible name, and I apologize. What I wanted was JStack, and I wanted for Python. I talked to a bunch of people, and a lot of the people I talked to, they had done this before, but it hadn't been, they hadn't codified it, and there was some trouble with it. We have a mix of web services and non-web services running Python. I wanted something that worked the same on all of them, and I wanted something that didn't require fighting or too much configuration. So what Socket Console does is you launch it inside your application, creates a Unix socket, so that way you don't have to fight over HTTP ports or anything, and then you can read, when you read from that socket, you pull down the stack trace. So the goals of this when I came into it is I wanted to work on multi-process and multi-threaded apps, no configuration pretty much, HTTP ports as I mentioned. That can be a real pain to manage. If each process is going to have its own HTTP port, then if you've got 90 some processes or you have dynamic ones, it can be really difficult to keep that all together. And I also didn't want to use any Unix signals just because I didn't want to trust that every application or library that I was instrumenting handled interruptions correctly. So quick little demo, what this one does, or example, this is a very silly little script. It starts up 4 threads, and in the main thread it calls this waiter, and the waiter calculates a random value and sleeps forever, or 500 seconds. And the socket console launch is what kicks that off. Kicks off the thread that is going to do that exposes the stack trace information. If this was a web app, like the main WSGI startup would be a good place to do that. So here's the output. Socket reader is a shortcut for communicating with each of those socket socket files. So we pull down the stack trace. I edited the paths just for clarity, but you can see that both of those threads are sleeping, and you can see the local values that are there currently. Now this is, because this is such a contrived example, I don't think it really gets to how useful that can be. So here's one that does a little bit more work. It's just a tiny script that connects via SQL Alchemy to a Postgres test database and executes PG sleep, which is just sleep for 15 seconds. And that's just long enough for me to run the socket reader. Now, the stack trace in this is not very useful. We know what it's doing because of the size of the script, but the locals are pretty neat because it just so happened that the statement is in a local variable. We know the exact statement that is running. And we've seen this happen for free, where we just think, this server's being a little slow. Let's poke this at it, and oh, a lot of these are doing this query. Let's go see on the database if that is backing up there. Both of these examples are basically frozen threads, but it works even when there's a lot of churn and a lot of activity, not just when it's totally stopped. Up next is a library written by Michael Schurter, the colleague I mentioned before, called mmstats or mmstats. He hasn't decided how to pronounce it, to provide a subset of what JMX can be used for to pull information out. And we've bouncing around some ideas for taglines. The proc file system for your application is kind of the best one for the Linux heads. We want to expose any data that we can calculate in a way that's easy to consume. We didn't want the writing to depend on any framework or any particular library in Python, and we want the reading to be able to be done from any language whatsoever. So what it does is it exposes a memory mapped file for each, in general, each thread, as long as there's one writer. And in that memory mapped file, there's a language-independent data structure. You've got a series of fields of whatever kind you want, and you expose it in Python as a model class. His goals behind this was trying to make a simple API, and very importantly, having a predictable and mostly minimal performance impact, because you don't want your monitoring system or your instrumentation to actually become a bottleneck in your application. And then to separate the writing and reading, which is useful in a heterogeneous architecture or environment, and when you have an ops team that is very good at their jobs, they want to use whatever they can use. So, as I said before, it's a single writer, multi-reader, which helps us bypass some needs for locks. When you're updating fields, there's no system calls. So even that is a little bit more predictable. It stays in the user space, and reading doesn't have any impact on what the writers are doing. Well, let's just see an example and see where we can go. So here is another stupid script. I excel at those. It increments up to 1,000 and updates a counter, and I guess it sleeps for a random amount of time. And I'm keeping a hold of some stats while I do this, incrementing counters, and well, that's about it. So I have this data. It's now exposed in this memory mapped file. What are some of the ways I could pull out that data? These two tools are the simplest ways to work with it. One is slurp stats, which just pulls from a list of memory mapped files, which would be any number of writers or any number of threads or processes or whatever you're doing, and just dumps all the metrics it can find. We just use that for testing sometimes, but we have put that into a watch command just to see it go over time. And then pull stats is really, really simple. It just shows you the difference between counters once a second. And nothing's going to win any beauty awards with it, but it does have its own use. And these simple ones especially can be useful for one-off scripts. I mean, doing some data migration or something. It's going to run for a couple hours, but if you can just take some time and expose the metrics ahead of time, then you don't have to worry whether you got your print statements correct, like every 10,000 operations you printed a dot or whatnot. But to go to another reader that's a little bit more useful, MASH is just it is a web server that you give it a settings file of where any applications might be that are exposing this data. It goes and finds them, exposes all of the counters there, or all the metrics that you've created. So the first two on the top there, the counter, or the localhost just shows from that counter application what's going on, and I can dig into the counter. But the two on the bottom are a little more interesting. That's from one of our running systems where we have, I don't know, like 24 processes on this one machine, maybe 36, and they're all reporting how many jobs they're processing at any one time. And so I can view them all individually or sum them up with a simple aggregator. Now, at this point, we've been able to expose data in a pretty easy way, and we're confident in the way that we can write that data out. But it's only useful now if we go and look at it. So, talking with the ops team and how we do it, we want to integrate this with the rest of our operations system. So, we use Isinga and the Nagios fork for monitoring, and P&P for Nagios to graph a lot of that data. So this is a check that pulls in that aggregated data about successes that we saw last time, and so we have a nice graph, and because it's a sort of agnostic format, Nagios is reading all that in. We can perform checks on any of the metrics or the data that we're pulling out, and it goes next to all of the graphs and checks that we're doing for every other part of our system. And because our ops team is so great anyways, they using whatever tools they like, and here they have a graph where they've pulled multiple hosts exposing that same sort of data and put all together. And at this point, because they have a heterogeneous architecture, and we have a monitoring system that works across the heterogeneous architecture, they can make a dashboard with this data and related servers and related data stores and other things, so we get a holistic view of what's going on right now with the related set of services and applications. So with MStats and Socket Console, this is very early in their lifetime, because this is sort of a practical problem we're approaching. We're looking for practical solutions. We talk to everybody that we meet about how they're approaching these problems, and everyone sort of got different approaches and different tools. And so one of the greatest things we've been doing is talking with people and learning about, well, what can we put together to make this more easily, or make this more, make applications easier to instrument and make them more useful to pull out data. So there are more fields to do, more measurement styles, especially some of the more advanced ones that are in the metrics library, and more readers and examples and plugins for common libraries so that we could just drop these into existing services without too much configuration. The unified web interface idea is that if we have a web service that takes an easy configuration file, we point at the various applications, and then you've got a dashboard for all of your Python processes on one machine. And that can be pretty useful. And now I want to talk especially about a couple efforts that have been going on in parallel that are public and open source. One is Scales, which is parallel to a lot of things we're doing with MStats. It's come a long way since in the last few months. It supports a variety of metrics. You instrument your Python applications, and data is exported either by an in-process web server or periodically by pushing to Graphite. And I'd say the primary difference in philosophy is under the hood, not in the external, where it does require locking in the thread port per process. But I highly recommend checking it out, and there's a lot to learn there in your own projects as well. And then one other that I just learned about today when someone sent me a message on Twitter is PyStuck, which is very much like Socket Console, and it uses the web server, embedded web server idea, so you give a port to your application, and then it has that same data. And I think he's got a better reader than mine, or better command line tool. This, as I said, is a practical problem. Many of us have solved it in different ways, and I'd like us to be able to learn from each other as we're managing all these services and building new ones, and find a set of tools and practices that make these solutions straightforward and easy to integrate. This should be the default when we deploy Python services, that we have all this information about it and that it takes less and less time to integrate and to apply them to each one. And with that in mind, we set up a new mailing list to discuss these projects and other ones, and we'll be sprinting on Monday and Tuesday. I'll be here on Monday and Tuesday, and Schmeichel will be sprinting remotely from Portland on Monday. I think we all need this, and it's within our reach. These are all solvable problems. Here's a couple of the projects that we were talking about, and I'm happy to show a little bit more. Thank you very much. This is my contact information and Michael's. There's the mailing list, and Urban Airship is hiring both in Portland and San Francisco, in case that's interesting to you. And if there are any questions, I'd love to hear them, or comments.
Are there any questions? We have time.
Yes.
Step up here.
Hi. I wanted to know, how do the tools, or what's planned with the tools that you're developing, and how well do they play with, for example, the Java console and the monitoring tools that already exist, for example, when using Jython or when using a JVM launched from a Python script?
So the question was how well these tools will play with existing Java tools,
Exactly.
or with in places where Python and Java are working together. And the answer
Yes.
is probably very little. The Java tools, the way JMX works is quite specific. However, if you take sort of the next layer up in the services that generally consume this data, like the raw data, like the monitoring services and other things, then that's the part where they can work together very well. This is all, both of those projects in particular are Unix specific. They won't work on Windows. Well, okay, they might work on Windows. I haven't tried that. But Jython isn't on our radar at all.
Okay. Thanks.
Do you think that things like PyPy, where you have kind of more of a VM layer, would help with kind of monitoring tools? Because I know JMX is more at the virtual machine layer, not so much. It's not a Java thing specifically, so is it a lot harder in Python just because you don't have that kind of bottom layer to instrument the tools apart from the language? Or?
That's a good question. So right. So a lot of the Java tools, they are built into the JVM, or they make use of systems that are built into the JVM. And an effort like PyPy definitely could expose a lot more or make it easier to expose them. The idea of just grabbing the stack trace, that's something that a lot of systems do at the VM or runtime layer. Like I know Go just integrate, or just resolved Schmeichel's feature request, which was to be able to get the stack trace at any one time. And I could see a point where it would make more sense to push that up to the interpreter level, but I don't think that we know enough about what exactly we want. We want the use cases from the JVM, but not necessarily the way they've approached it. That said, the tracing stuff that they're working on in PyPy is really cool, and that is the kind of data that I'd like to see exposed, as well as this sort of application-specific data.
Can you comment some on the PyMX project as it relates to what you're working on?
The last time I looked at that, I hadn't seen any updates in a very long time. I don't think it's maintained. If I'm wrong, then I definitely should look. And I don't know that what their goals were, whether it was to make this exact same thing or whether to just pull out the data they needed in order to help their operations. But I think focusing on the practical aspects as opposed to the encompassing vision is going to be the best way forward to being able to make the most out of our applications data.
Any more questions? I also would like to point out, if there are somebody is more interested in this topic, there's some space for open space. So if you like to, you can organize open space and people can talk about it.
That's a good idea.
If there's no any more questions, then thank you very much for your very interesting talk.